All right, logicians, we're going to be talking about sections E and F of chapter 1 in this video. Arguments fall into basically two categories. There are deductive arguments and there are inductive arguments. Now, most of our class, we're going to be talking about deductive arguments, but I want you to be able to distinguish between deductive and this other kind, inductive. Now, the difference is this. A deductive argument is one which is making a certain kind of inferential claim. It's claiming that if these premises are true, then the conclusion follows necessarily. It's not possible for the premises to be true, but the conclusion to turn out false. An inductive argument is making a more modest inferential claim. It's claiming that if these premises are true, then the conclusion is probably true. It's possible that the conclusion could turn out false, but it's likely that it's going to be true. That's the basic idea. Now, in the wild, when you see arguments, you can tell which kind of argument is being made. You can tell which kind of inferential claim is being made, sometimes through the keywords or phrases that are used. When somebody says that, X, Y, Z are true, and therefore necessarily, certainly, definitely this conclusion follows, they're trying to make a deductive argument. But when they say, well, if this is true, then this is probably true, this is likely to be the case, they're making an inductive argument. Now, again, these arguments have different strengths. A deductive argument is making a much stronger kind of claim about the evidence supporting its conclusion. An inductive argument is making a more modest claim. And you'll see inductive arguments used primarily in science, legal settings, sometimes moral settings, statistics. Deductive arguments are mainly confined to mathematics, to geometry, and to certain kind of conceptual claims made in philosophy. Philosophy can use both. So let's take this example. Most college freshmen have part-time jobs. Sue is a college freshman, thus Sue has a part-time job. What kind of claim is that? What kind of argument is the person trying to make? Well, it seems like you look first of all for a clue word, a keyword. I think the keyword here that you want to tune into is the word most. Most college freshmen have part-time jobs. And so I think the implication here is not that absolutely for certain Sue has a part-time job, but probably Sue has a part-time job. It's a claim that involves what's usually the case. That makes it an inductive argument. Now, as with all arguments, there's two kinds of levels of analysis that we're going to be doing. One is we want to look and see if the statements that are made are true. But what's more proper or distinctive to logic is we want to do logical analysis. That is, we want to analyze if those premises were true, and they may not be, but if they were, what kind of support and how much support would they provide for the conclusion? In other words, what's the relationship between the premises and the conclusion? When you're doing truth analysis, you're asking, is this statement concretely, what's it saying is actually true or false? Logical analysis is on the relationship between the statements, regardless of whether they're true or false, just what kind of support do they give each other? Now, when we run logical analysis on a deductive argument, we're going to be working with the concepts of validity and soundness. Well, with logical analysis, we're working with the concept of validity. Now, validity is the success term for a logically correct deductive argument. You need to memorize the technical definition of validity. And here's what it is. If the premises were true, and they don't need to actually be true, but if they were true, would they necessitate the truth of the conclusion? That is, would they make it impossible for the conclusion to be false? If they do necessitate the truth of the conclusion, that's a valid argument. But if there's any possibility whatsoever that even if these premises were true, the conclusion could turn out to be false, it is not a valid argument. It is not logically correct. Now, in ordinary life, people use this word valid in all sorts of like squishy, vague ways. That's fine. But in this class, validity only means this technical definition, and you must memorize it. Now, it's great when an argument is valid, but that's not all there is to making a good deductive argument, because we also want to run the truth analysis. That is, even if the argument is logically correct, are the premises actually true? Now, if you have an argument where it is valid and the premises are all true, it gets the A+ gold star designation. It is a sound argument. But if it is either not valid or one of the premises is false, it is unsound. It's unsound. So here's your flow chart for evaluating deductive arguments. First, you ask if it's valid. That is, if the premises are assumed to be true, is it impossible for the conclusion to be false? If the answer is no, it's still possible for the conclusion to be false. It's not a valid argument. And if it's not valid, it's not sound. But if the answer is yes, if these premises are assumed to be true, the conclusion would have to follow necessarily, then it is valid. Great, you passed test 1. But now we've got to run the truth analysis, and we've got to ask, well, are the premises actually true? Again, if the answer is no, if at least one of the premises is false, it's unsound. If the answer is all the premises are true, then that argument is sound. And that means that the conclusion must be sound. You should accept the conclusion on the basis of that argument. So that's how you run the evaluation. Now, this next part is probably the hardest part of this chapter, okay? We want to sometimes separate logical analysis from truth analysis, right? Because the validity of an argument, whether or not it's logically correct, it depends exclusively upon the structure of the argument, not upon what it's actually talking about. It's all structural. So take for example, this argument. All beagles are dogs, all dogs are mammals, therefore all beagles are mammals. This happens to be a valid argument. But if you didn't know and you were trying to figure it out, you might get kind of tangled up thinking about beagles and dogs. Like, wait, what is a beagle? Is that a species of cat? Or like, what's the technical definition of mammals again? And you'd be all thinking about animals. For the purposes of determining logical correctness, it doesn't matter what we're talking about. It doesn't matter whether the actual statements are true or false. We're just trying to figure out whether an argument with this structure would necessitate the truth of its conclusion if the premises were true. So you can actually just like plug in capital letters for the terms. Make beagles B, make dogs D, make mammals M. And here's what you get. The point is, any argument with that form, no matter what you plug in for B, D, and M, it's going to be valid because it's structure alone, not the actual content, that determines logical correctness. And this leads us to a method of determining counterexamples for the validity of arguments. This is where things get mind-bending, okay? If you want to come up with a counterexample to a statement, that's nice, that's easy. Like if you say all whales are blue, I can like point to an orca whale and say, no, that one's black and white, it's not blue. But coming up with a counterexample to the validity of an argument is different because it's not about the truth of an individual statement. It's about like the structure. So here's what you want to do. You want to boil down the argument to the mere form, right? With these capital letters instead of actual concrete terms. And then you want to ask yourself this. Is there any like substitution that I can make? Are there any terms that I could plug in for these letters that would make all the premises turn out true, but would make the conclusion turn out false. If there is a set of terms that you can plug in that will make the premises all true, but the conclusion false, then you've come up with a counterexample to the validity of that argument form. For example, if you had an argument with this form, all B are S, all G are S, therefore all B are G, you could plug in to test it. Well, I'll make all the B's men, I'll make S human beings, I'll make G women. So now you've got all men are human beings. That's true. All women are human beings. Also true. Therefore, all men are women. Wait, pause, false, not true. Now here's the point. You've shown that there are arguments with this structure that do not necessitate the truth of their conclusion. And if that's even possible, then no argument with that structure is valid. It's invalid. Because with a valid argument, just based on its structure alone, anytime where the premises are all true, the conclusion's false. Now, how do they come up with these? Like, why do they pick men, human beings, and women? How do they know to do that? Well, you have to use some creativity to run through sets of items to test these. Now, if an argument is valid, you'll never be able to come up with a good counterexample. But if it's not valid, in principle, you can come up with one. So let's try another one here. That's interesting. That's boring. No C are B. No C are S. Therefore, no B are S. Now, our question is this. Is this a valid argument? That is, any argument which has this form, does it always necessitate the truth of the conclusion? And I'll tell you, it's not valid. You will be able to come up with a counterexample. You can come up with a set of terms, a substitution for C and for B and for S, which make the premises true, but the conclusion false. There may be lots of cases where the premises are true and the conclusion is true. You'll be able to come up with those too, but you'll also be able to come up with one that makes the conclusion false. For example, you plug in crocodiles, boas, and snakes. No crocodiles or boas, true. No crocodiles are snakes, true. Therefore, no boas or snakes, false, absolutely not. This takes creativity and patience to come up with counterexamples. You can try, humans, men and women. You can do the crocodiles, boas, snakes. You can try plugging in dogs, beagles, mammals, isosceles, equilateral, triangles. Different sets of items that have different kinds of relationships will be useful to you in coming up with counterexamples for these sorts of arguments. Enjoy.